Hello class 12 science. In our yesterday's class, we have seen about Arrhenius equation and we have derived the equation for it. Now today we are going to do the numerical based on it. So the question is, the rate constant of a reaction is 1.5 in 10 to the power 7 per second at 50 degrees Celsius and 4.5 in 10 to the power 7 per second at 100 degrees Celsius. Calculate the Arrhenius parameter A and EA. So you need to calculate the Arrhenius parameter A and EA activation energy. Now we know from Arrhenius equation, this equation we have already derived. If you have noticed, log K2 by K1 equals to EA by 2.303 R 1 by T1 minus 1 by T2. Now the givens in the question, the first one is the rate constant, so the value for K1, and this is T1. So please convert this temperature into Kelvin. Okay, try to convert the temperature in Kelvin. Similarly, this is K2 and 100 degrees Celsius is T2. Now we'll just substitute that value. K2 4.5 in 10 to the power 7, K1 1.5 in 10 to the power 7, EA will remain as it is, 2.303 R, the value for R, that is universal gas constant, it is 8.314, okay, joule per Kelvin per mole, and the value for T1, 50 degrees Celsius is converted into Kelvin, so it becomes 323, and 100 degrees Celsius when converted into Kelvin it becomes 373. Now when you just simplify it, okay, this value you can find with the help of the calculator, because this 10.7 and 10.7 will get in, so it becomes 1.5 by 4.5 by 1.5, so 15.3, so it will become log 3. So you'll calculate the value for log 3 from this, and when you just simplify it, the value for EA activation energy will come as 2.2 in 10 to the power 4 joule per mole. Okay, fine. Now we'll use another equation to find the Arrhenius factor A. Okay, now log K equals to log A minus EA by 2.303 RT. This also equation we have seen while deriving the final expression for this one. Now log K, you can take any value, either K1 or K2. Okay, so we have taken K1 1.5 in 10 to the power 7, so log A as it is. So we have just found out the value for EA 2.2 in 10 to the power 4, 2.303 is remain as it is, the value for R is 8.314, and T we have taken the initial T1, okay, 323. Now here we need to find the value for log A. So when you just simplify it, the log A will come certain values, and the value for A, okay, you can keep it log A also equals to something, or this has been taken as anti-logarithm. Okay, this has been taken anti-logarithm, so A equals to 5.42 in 10 to the power 10 per second. This is how we do the numerical based on this Arrhenius equation. Now assignment for today, a similar type of question. The rate constant of a first order reaction becomes 5 times when the temperature is raised from 350 Kelvin to 400 Kelvin. Okay, so here what he can do is, the rate constant is not given, so you can assume the first rate constant as x, and it becomes 5 times, that is the final, that is K2, it becomes 5x we can say, and temperature 350, T1, T2. Okay, calculate the activation energy of the reaction. So using the formula you calculate the value for EA. Next, question number 2, for a first order reaction, if rate constant at 17 degrees Celsius is 2.8 in 10 to the power minus 5 per second, and at 27 degrees Celsius it is 2.8 into 10 to the power 4 per second, calculate the activation energy for the reaction. Okay, so you need to calculate the activation energy only. And question number 3, define activation energy. So activation energy, define it. What is it?